If you shrunk Earth to the size of this model, this is how large Jupiter would be in comparison. But to compare Jupiter to the Sun? Well, the Sun wouldn't even fit in the frame. You'd have to zoom way out. Yeah, if Earth was 12 centimeters, 4.7 inches in diameter, the Sun would tower at 13 meters, 43 feet. To Digipeter holding his Earth model, the Sun would look like a school bus. And that's nothing compared to what you're about to see. Today, we're going bigger and badder to reveal the absolute largest objects we can find in the entire observable universe. And let me clarify something. We're talking physical size, not mass. We often talk about planets and stars as large and massive. Well, when I say large, I mean the diameter of an object, top to bottom. And when I say massive, I mean the mass, which is the amount of matter stuffed into an object. You can have an incredible mass, but be physically tiny, like a dense black hole or a neutron star. Those are not going to make it on our list, because today we're talking size, and things are going to get huge. In our own solar system, Jupiter is the largest planet we've got. Jupiter is so huge that you could fit 1,321 Earths inside of it. You could say that Jupiter plays an outsized role in our solar system. Huh? This gas giant may be the reason that a planet like Earth can sustain life at all. Yeah, because of its size and gravity, well, Jupiter deflects comets and asteroids so that they don't constantly slam into Earth, causing dinosaur-killing kind of events. Even more importantly, because of where Jupiter sits in the solar system, it helps the inner planets maintain nearly circular orbits. For Earth, a circular orbit means a stable climate over long periods of time. Thanks, Jupiter. Now, it may be the largest planet in our solar system, but it's nothing compared to the absolute largest planet scientists have ever found. Q Rox 42BB. About 470 light years from Earth, there's an absolute monster of a gas giant, Rox 42BB. If Earth was a ball 12 centimeters in diameter and Jupiter was 1.35 meters in diameter, Rox would be as wide as an elephant or a one-story house. And it's not just another exoplanet. Something isn't right about Rox 42BB. You see, gas giants are made of the same stuff as stars, helium and hydrogen. The only difference between them is how much mass they're packing. If a gas giant has 13 Jupiter masses, it starts having nuclear fusion inside and turns into a brown dwarf star. Hey, did you know that there are more atoms in a single glass of water than there are glasses of water in the ocean? Now, Rox 42BB is a cosmic heavyweight, and it has a mass of 9 Jupiters. It's too light to be a star, but way too massive to have formed like a normal planet. Normal planets are built slowly, piece by piece, from the leftovers of a star's birth. But Rox 42BB might have skipped that step. Instead of growing from dust, it may have collapsed directly from a massive cloud of gas, just like a star does. But because it didn't have enough material to jumpstart nuclear fusion, it never ignited. That's what scientists call a sub-brown dwarf, a failed star trapped in the body of a planet. If you could drift through its thick, stormy atmosphere, you'd find that it still has a core that's glowing cherry red from the heat of its birth. Okay, if you're wondering why there aren't any supersized rocky planets on our list, well, that's because rocky worlds don't grow that big. The title for the largest rocky planet goes to TOI 849b. And if Earth was 12 centimeters tall, TOI 849b would only be about 40 centimeters in diameter. Yeah, rocky planets don't grow much larger than 4 times the diameter of Earth. But TOI 849b isn't just an oversized rock. It's a dead core of a gas giant that had all of its atmosphere stripped away. So yeah, when you look at largest planets, you gotta look at things like Rox 42b, a planet on the verge of being a star. And those are the next bigger, badder, brighter objects we're looking at. Stars. Stars are huge, and we have a pretty big one right here at home. The Sun is by far the largest object in our solar system, with a diameter of 1.4 million kilometers, 865,000 miles. It dwarfs both Rox 42b and Jupiter. In our size comparison simulation, where Jupiter is 1.35 meters in diameter, the Sun is 13 meters wide. Yeah, that's the kind of jump in size you get when you level up from planets to stars. The Sun is not just huge in size, it also accounts for 99.86% of all the mass in the solar system. That means all the planets, moons, asteroids, comets combined are just leftover crumbs, about 0.14% from back when the Sun was born. You're lucky that space is a vacuum and that sound can't travel through it, because if it did, the Sun would be deafening. Yeah, the Sun is so incredibly loud from its constant nuclear explosions that even from 150 million kilometers away, it would sound like a lawnmower vibrating at over 100 decibels right in your ears. On top of that, about 10 times a year, you'd be assaulted by the thunderclap of X-class coronal mass ejections, CMEs. These can release the energy of hundreds of nuclear explosions all at once. Now, our star is pretty special to us, but it's not the largest or most massive one out there. Neutron stars, white dwarfs, and magnetars pack a lot more mass, but they're all smaller in size than the Sun. Yeah, they crush all their mass down into a tiny space. And since we're talking about the size and not mass, those extremely massive space objects, they didn't make our list. And our Sun is a medium yellow dwarf. It's nothing compared to what we're going to find out there as we go deeper into the universe. Like this star, Sirius A, also called the Dog Star. You can see it in the night sky with your naked eye. Out of all the stars in our sky, Sirius A is the brightest. And not because it's the biggest, it's just very close. It's a mere 8.6 light years away, making it one of the 10 closest stars to Earth. But it is bigger than our Sun. It's about 1.7 times larger. In our comparison, Sirius A would be 22 meters in diameter. But compared to some of the largest stars, Sirius A is still just a small player. It's a bright, impressive neighbor for sure, but it's nothing compared to what happens when a star starts to reach the end of its life. Take Pollux, for example. It might be cooler than our Sun, but it's 9 times larger. Pollux is a red giant, a star that's begun to run out of fuel and is puffed up to a staggering 12 million kilometers in diameter. It's a bloated, glowing glimpse of the Sun's future. Yeah, this exact same thing will happen to our Sun in about 6 billion years. Scientists calculate that the red giant version of our Sun will definitely swallow Mercury and Venus, and possibly Earth as well. Okay, now, while Pollux is impressive, well, we're gonna go even bigger. This is Arcturus. It is a true giant, measuring 18 million kilometers in diameter. To put that in perspective, you could line up 25 of our suns across its middle and still have room to spare. Arcturus is 37 light years away. It's the fourth brightest star in our night sky, shining with the intensity of 113 suns. But Arcturus hides its true power. Because it's cooler than our star, most of its energy isn't light that you can see. It's heat. Yeah, this star pumps out 215 times more thermal energy than the sun, turning it into a cosmic furnace that would incinerate anything that gets too close. Arcturus is one of the oldest stars in our galactic neighborhood. Scientists think it might be a relic from a completely different galaxy that the Milky Way swallowed billions of years ago. It's an ancient extragalactic traveler passing through our corner of the universe. Still, as massive and mysterious as this giant is, it's about to look completely insignificant compared to what comes next. This is a literal supergiant, Beetlejuice. It's about 700 times bigger than our sun. If Earth was a globe 12 centimeters in diameter, this giant would be slightly taller than Mount Everest. It's so large that if you placed it at the center of our solar system, its surface would extend past the orbit of Mars and could even reach Jupiter. And now, Beetlejuice is ready to explode. Yeah, this giant is dying, burning through the very last of its fuel. In 2019, Beetlejuice mysteriously dimmed to 60% of its usual brightness. Scientists thought it might finally go supernova, but turns out it was an enormous surface mass ejection that coughed up a cloud of dust, temporarily blocking its light. Beetlejuice could collapse and explode into a supernova tomorrow, or it might hold on for another 100,000 years. In the grand billions of years timescale of the universe, that's less than a nanosecond. When it finally does blow, it'll be so bright that for weeks you'd be able to see it shining in the sky, even during the day. Now, even a puffed up red supergiant like Beetlejuice can't compete with the ultimate heavyweight of the cosmos, Stephenson 218. To even fit this monster into our comparison, you'd have to zoom way out. If Earth was a 12-centimeter ball, Stephenson 218 would be a sphere 28.3 kilometers, that's 17.6 miles wide. That's more than 3 Mount Everests stacked on top of each other. If you replaced our sun with Stephenson 218, its outer edge wouldn't just stop at Jupiter. It would reach past the orbit of Saturn. It would swallow Mercury, Venus, Earth, Mars, Jupiter, and Saturn whole. This star is so huge that if you hopped a ride in a plane flying at 900 kilometers per hour around its surface, it would take you 1,500 years to complete just one lap. You could fit nearly 10 billion suns or 13 quadrillion Earths into the space that Stephenson 218 takes up. This largest of stars shines 500,000 times brighter than the sun. That's 500,000 times brighter, but it is 19,000 light years away. So as huge and bright as it is, you can't see it from Earth unless you have a powerful telescope. So there you go, the largest star in the universe. But our hunt for the biggest objects doesn't end at stars, because there are much larger and much scarier things out there. Next up is an object so unimaginably vast that scientists had to invent an entirely new category just to describe it: the ultra-massive black hole. Yeah, Stephenson 218 was big and fluffy. Ton 618 is pure gravitational nightmare fuel. And it shines brighter than 100 trillion stars because it eats mass so fast. Ton 618 is 10 billion light years away. 10 billion light years away. But if you put it in our hypothetical scale next to Stephenson 218, this black hole is the size of the actual moon. With Earth being a ball 12 centimeters in diameter, Ton 618 would be 3,760 kilometers across. In real life, Ton 618 is about 40 times the width of our entire solar system. While we're strictly talking physical size today, when it comes to black holes, you can't help but be pulled in by their mass. Ton 618 packs an incredible 66 billion times the mass of our sun. It's large, but also supermassive. Now, as terrifying as it is, Ton 618 is one of the biggest black holes in the universe. But even then, it's not the biggest. Phoenix A star is a black hole that has an event horizon that stretches 590 billion kilometers in diameter. If Earth was the size of that 12 centimeter ball, Phoenix A star, the black hole, would be a sphere 5,500 kilometers in diameter. That's almost the size of the actual planet Mars. This is the absolute largest known black hole in the universe. It has a mass of 100 billion suns. That's a 1 followed by 11 zeros. It's so big that astrophysicists don't think it could have formed by eating stars like a regular black hole. There is literally not enough time in the universe for it to swallow that many stars and get this huge. Phoenix A star might have been a primordial black hole that formed directly from the raw energy of the Big Bang, long before the first stars even began to flicker into existence. It's big, right? Almost incomparably big, but it's not the biggest object in the universe. Not by a long shot. Hang on as we scale way up to whole galaxies. Let's start right here at home, in the swirling city of the 400 billion stars we call the Milky Way. It's a massive spiral galaxy, 100,000 light years across, and we're tucked away on the Orion Cygnus arm, basically the galactic suburbs, about halfway to the outer edge. Well, to really wrap your head around that distance, you have to look at a single light year. Imagine a beam of light. It could race around the entire Earth 7.5 times in just 1 second. Now, multiply that by every second in an entire year, and you get 9.5 trillion kilometers. That is just 1 light year. To get across our galaxy, you'd have to make that trip 100,000 times. If Earth was the size of this 12 centimeter ball, the Milky Way wouldn't just be the size of an actual city or country, it would be the diameter of our actual real-life solar system, roughly 15 billion kilometers across. It's way too large for our simulated scale, so I can't even show it. Just picture a tiny grain of sand next to the Milky Way. Yeah, that would be the sun. It sounds enormous, but on the scale of the universe, it's really not that big. Even our next-door neighbor galaxy, Andromeda, is twice our size, spanning 220,000 light years. And then there's the behemoth known as IC 1101, which stretches out 4 million light years. Now, believe it or not, things do get even bigger. At this point, we're starting to test the boundaries of human comprehension and push the very definition of an object in space. Take Kipu. It's between 425 million and 815 million light years from Earth, and you can still see it in the night sky without a telescope. Kipu is a twisted, branching rope of glowing galaxy clusters that looks like a nervous system. On our hypothetical scale, compared to this model of Earth, Kipu would be 20 light years long. In reality, it's 1.3 billion light years across. It also has the mass of 200 quadrillion suns. Just to be clear, a quadrillion is a million billion. So 200 quadrillion is a 2 followed by 17 zeros. Scientists think Kipu is the largest connected structure in the universe. It's like a massive glowing chain of 13,000 Milky Ways linked end to end. Imagine that. But the universe still doesn't stop there. There's at least one thing bigger, and it might be too big to exist. This is the Hercules Corona Borealis Great Wall, a supercluster spanning 10 billion light years. To give you an idea of how absurd that is, it takes up roughly 10% of the entire observable universe. Let's go back to our hypothetical scale one last time. Earth was a 12 centimeter ball. Jupiter was a modest 1.35 meters, and the Sun was as large as a school bus. Now, on the same scale, the Hercules Corona Borealis Great Wall would be 150 trillion kilometers long. That's 157 light years. Even on our scale, these numbers don't even make sense anymore, and this model of Earth is useless. The Hercules Corona Borealis Great Wall is so big that even the scientist who discovered it thought it was too big to exist. Based on our current understanding of how the universe formed after the Big Bang, something this large shouldn't even have had time to pull itself together. This cosmic anomaly challenges everything we think we know. Okay, for now, we've reached the absolute limit of what we can see and understand. But in a universe this big, there's always something larger, darker, and more mysterious waiting just beyond the horizon. But some dark and lurking things don't have to be unimaginably massive to be deadly. Take a black hole. Even a nanosecond inside it would turn you into human spaghetti. But that's a story for another What If.